This is the mobile application that we have developed for our project. This is the home page. In here we have two fields, vehicle number, location. After fill this fields, we have to click find a parking space. Then it will shows the availability of the free parking spaces. So we have to click book in order to make a reservation, and here it will say successfully booked for this vehicle number in this location. The slot number 3 is assigned to this particular vehicle. Then we can see this database data in our real-time database Firebase. So here we have those datas here. This is the vehicle number and this is the assigned parking slot. This is the Meet App Inventor tool that we have used to design our mobile application. So here we can see those design pages here. This is the home page and this shows the availability of the parking spaces, and here the final reservation. And this is the block view of our designed mobile application. So here we set up all the things for the Firebase DB1, and here we set that in the database the maximum available slots as 8. This can be any value, like according to our requirement. It can be 100, 200, anything. And here we mention the locations. Here we have only mentioned one location. Then if we click done button, and then it vertically arranged pen 1 will be visible to the user. That's all about the mobile application development. So here it's a Raspbian OS in Raspberry Pi. Here we have Firebase Python code and our main Python code. So in Firebase code, it's for a connection between our program to the real-time database. So here we gave our Firebase URL and so on, like that. And in main program, we have configured the Firebase again, and we have imported all the necessary files here for the PyCamera and all. So in here we have set the camera as PyCamera and the resolution and the frame rate. So here we have frame. So when we execute this program, it will show a camera frame, and if we click simple S in our keyboard, then it will capture that vehicle plate image, and it will after capture the image, that this will convert that image into a grayscale. And after this edges should be mentioned because when we capture the image, the exact rectangular edges should be captured perfectly. And if that frame doesn't detect any images, then it will show no counter detected. And if detect anything, and then the image get into a image processing algorithms, and it will shows that text, the captured text will display here. The detect number is, and the text will be displayed here in some values. So here we have the settings for our Firebase database. So here we initialized our config Firebase. So this is the code for our image processing part. So here we are going to execute our project. Now it will show our PyCamera's frame a little bit. The frame is came. So we have to cover the all edges of our number plate, otherwise it won't detect the number exactly. So here we captured our image. It shows some here we captured our vehicle number here, so but it gives some errors. Let's try again. So when we try to capture the image, it should cover the all rectangle edges. Yeah, now it's captured that image, and it says here the allocated lot number is 3 for our this vehicle number. It's allocated parking slot number 3, so it's display here.
This is the Arduino code used for the IR sensor detection. In here, there are 3 variables for the IR sensors. These are the pins used for those IR sensors. We can add any number of IR sensors here. And there are 3 states of those IR sensors, and the variables for seconds, minutes, hours, and for the toll. Then in here, it configures the 3 pins to work as inputs. Then the process begins here. First, by this line, IR sensor 1 data is assigned to the variable IR sensor 1 state, this variable. Then it checks whether the state of IR1 is 0. It means whether there is anything in front of the IR sensor. And if so, it prints as detected. And there is a delay to make sure a vehicle is parked or something went wrong with any barrier or something. After the delay, it again checks IR state at this line, and if it's 0, it gets the idea that a vehicle is parked. Then it prints this. Then as long as the state equals 0, it starts the time by increasing seconds. Then the seconds are converted to minutes, and minutes starts to increase. Then after that, similarly, the minutes are converted to hours. Then again the state of IR1 is read by this line. After that, when the vehicle exits the gate, there is another IR sensor to detect the vehicle and give the toll amount. This is the toll calculation. For that, it uses IR sensor 2. First, it reads the IR data by this line, and if it gives 1, it means a vehicle has arrived the gate, and it leads to calculate the toll. In here, for 1 minute, the fee is 5 rupees. We can change the number. Then after that, it will print the toll. We'll run the code now. Compiling. serial monitor. When the IR detects something, it prints as detected and waits to confirm whether it's error. We'll see. If not, it starts the time as sets of 60 seconds. For each set, it calculates the toll as 5. It again calculates from 1, and here we have only one set. One and did not reach the second one, so it stops here, and when the vehicle is come to the gate, it will like this. It prints the toll as 5. This is the hardware structure of the IR sensor detection. In here we use this IR sensor, and that should placed in parking slot, and it will detect whether vehicle is parked or not. And this IR sensor should place near the gate to detect vehicle exits. In here both have 3 pins. The rightmost one is this red one. It is the VCC one. In both it's the VCC one. It gets 5 volts from the Arduino, and the middle one, it's the ground one. It's grounded in here. And this white one, and in this IR it's the orange one. Those are the outputs of these two. In this IR the output is here, the second pin, and for this IR it's the third pin. Those are connected to the pins 2 and 3 in our code.